Hello, Doctor. We are from Group 1, and this is our presentation. These are our group members. So, to start off, let me start by providing a brief introduction about the 737 MAX crash and grounding. So, to begin with, the Boeing 737 MAX was once a symbol of modern aviation excellence, experienced a dramatic fall from grace as a result of two catastrophic crashes. These incidents, which resulted in the death of 346 people, were traced back to a malfunction in the aircraft's Maneuvering Characteristics Augmentation System (MCAS) designed to prevent stalling. Both crashes occurred shortly after takeoff. Furthermore, in the aftermath of the crash, aviation authorities worldwide grounded the 737 MAX, underscoring the severity of the crisis and the urgent need to prioritize safety. The economic impact was profound, affecting not just the airlines and aircraft manufacturers, but also the broader global economy, with the grounding and production suspension significantly impacting the US GDP. The disruption extended through the entire supply chain, from small suppliers to multinational corporations.
Good day to Doctor. I'm Wen-Sing. So next I'll continue for the second part, which is background research. So the first is economic impact. The Boeing 737 MAX crash have been indirectly caused by several economic factors such as market competitiveness from its main competitor, Airbus, cost-cutting pressure to minimize production costs, and also profit prioritizations, which Boeing prioritized meeting financial targets over safety consideration.
Boeing's culture often prioritizes cost-cutting over safety. Cultural differences between Boeing and international regulators influence safety regulations interpretations. High-profile crashes like the 737 MAX weaken the public trust in aviation. Restoring trust requires transparency and prioritizing safety over profits.
Today's Doctor, I'm Elaine. Move on to technological impact. The Boeing 737 MAX crashes were caused by several technological issues. First, MCAS system flaws led to unexpected activations due to insufficient testing. Next, faulty air-on-air sensors caused loss of control and also revealing design flaws. Additionally, supply chain and production challenges affected their quality control, with fragmented supply chains and pandemic-related workers turnover impacting the safety.
Next, for the regulatory factor, the 737 MAX crash and grounding reveal significant regulatory issue affecting the global aviation industry. Authorized the FAA and EASA play a crucial role in ensuring the safety of the Boeing 737 MAX, raising the important question about the safety regulation. The grounding led to cancelled flight, financial losses, and the damaged reputation for the airline, highlighting the need for better collaboration between the regulator, manufacturer, and the airline to improve the safety and prevent the future incident. So during the crisis, airline have to comply with the regulatory mandate, including the safety check, software update, and the pilot training. So this situation underscores the importance of honesty, responsibility, and constant vigilance to protect the passenger and maintain the industry thrive.
Aviation companies must prioritize safety over than the profits. The 737 MAX incidents raised the ethical concerns about the Boeing's communication of risk and safety warnings. Compliance with regulatory requirements is crucial. The 737 MAX grounding highlighted the need for ethical decisions that consider all stakeholders, not just shareholders.
So, moving on to legal systems and government factors, the Boeing 737 MAX crashes reveal critical issues in the aviation industry's legal and regulatory systems, particularly concerning the MCAS. The crashes expose flaws in Boeing's design process and regulatory oversight, including Boeing's failure to fully inform pilots about MCAS and the lack of specific training on the system. The crisis underscores the need for significant reforms in corporate ethics, government oversight, and the empowerment of engineers to prioritize safety in the aviation industry.
Move on to a case study of Airbus A320neo. It has better aerodynamics and engines for improved fuel efficiency and reduced emissions. Initially succeeded but later faced technical and safety issues. For historical context, despite its success, the A320neo had engine faults, flight control issues, and sensor failures. Indigo grounded several planes due to Pratt & Whitney engine problems, highlighting its reliability problems. Move on to key incidents. The Airbus A320neo faced global incidents, including engine breakdowns, causing widespread disruptions for Lufthansa and similar issues in Asia and Latin America. Due to ongoing Pratt & Whitney engine problems, Lufthansa plans to use older A320 models and lease additional aircraft. Airbus A320neo was grounded due to engine and flight control issues. Regulatory demands lead to collaboration between airlines and manufacturers like Delta Airlines working with Airbus on engine problems. This caused operational disruptions, financial losses, and significant investments, emphasizing the importance of regulatory oversight for safety and confidence.
So net for the regulatory responses, the grounding of the Airbus A320neo prompted significant regulatory responses with the authorities like the FAA and EASA working closely with the Airbus and engine supplier to address the safety concerns. So regulatory authorities play a crucial role in overseeing the implementation of modification, ensure the compliance with the stringent safety standard and regulation, that highlighting the collaborative effort between the regulatory bodies and the industry stakeholders to enhance the safety. For the return to service and long-term implication, the intensive collaboration between the airline and manufacturer was essential to conduct detailed examination, carry out necessary upgrade, and ensure the comprehensive safety assessment before the aircraft could safely return to operation. So in conclusion, the grounding of the Airbus A320neo emphasized the crucial role of regulatory monitoring in safeguarding public safety and maintaining the trust in the aviation sector. It showcased the industry resilience and dedication to enhance the safety through collaborative initiatives involve regulatory authorities, airline and manufacturer. Looking ahead, the enduring implications stress the significance of continuous vigilance, ongoing improvement, and the priority of safety to uphold the airworthiness and dependability of commercial aircraft.
Moving on to the case study DC-10, the McDonnell Douglas DC-10, despite initial popularity, faced safety issues, notably the 1979 American Airlines Flight 191 crash due to the engine parent flaws. These incidents prompted regulatory actions to enhance the safety and reliability. The 1979 crash of American Airlines Flight 191 exposed the critical flaws in the DC-10's design, leading to the significant regulatory actions and improved safety standards. The FAA grounded the DC-10 for safety upgrades. This grounding had significant operational and financial impacts on airlines and manufacturers.
Next is regulatory response. The Federal Aviation Administration adopts a new airworthiness directive for all the Boeing Company Model DC-10 to address specific safety issues identified after the DC-10 crash. FAA mandated improvements to the venting system in DC-10 aircraft and enhanced structural inspections of critical components of DC-10. This regulatory response emphasized the importance of continuous safety oversight and regulatory intervention to address emerging safety concerns and enhance the airworthiness of commercial aircraft. Next, we proceed to return to service and long-term implications. After addressing the safety concerns and making improvement, the DC-10 undergoes a process of returning to service to ensure that all identified safety concerns have been addressed and the aircraft meets all applicable airworthiness standards and regulatory requirements. The long-term implications of the action taken by regulatory authorities included changes in safety regulations, industry practice, and public perception, which highlight the industry resilience and capacity for continuous improvement in safety and reliability. In conclusion, the case study of DC-10 crash issue highlights the importance of proactive risk management, regulatory compliance, and collaborations to ensure safety and reliability.
Boeing addressed 737 MAX issues with an MCAS software update, improved the pilot training, and increased the sensor of redundancy to enhance the safety. Regulatory authorities implemented stricter oversight and testing of software updates for the 737 MAX, ensuring through the assessment before the aircraft returned to service.
The second current solution is pilot training and manual. The Federal Aviation Administration (FAA) scheduled proposing training revisions for Boeing 737 MAX to help pilots avoid overly reliance on autopilot and to ensure they focus on flight path management. Besides, the training manuals were updated to include detailed emergency procedure for addressing potential malfunctions or failures, particularly those related to flight control system, so that the pilots were trained to recognize and respond to abnormal situations promptly and effectively, prioritizing the safety of the aircraft and its occupants.
Moving on to flight control enhancement, current flight control solutions enhance safety and efficiency through adaptable multifunctional FCS architectures, real time adaptive control systems, and rigorous verification and validation processes. These systems, tested and certified under strict guidelines like RTCA and so on, reflect the aviation industry's commitment to continuous improvements, innovation, and maintaining high safety standards.
For current solution for increased pilot control and feedback, Boeing commitment to increasing pilot control and feedback is evident through engagement with the pilot during the testing and validation of system changes. So this approach not only address the technical improvement but also prioritize the real-time feedback from the pilot who operate the aircraft. So this interactive process refine the aircraft system and integrate the pilot feedback into the outgoing development and improvement effort. Next, for corporate and cultural, in response to the 737 MAX crisis, Boeing has undergone a significant corporate and cultural transformation to address its challenges. So this transformation involved the fostering a culture of honesty and responsibility within the company and reshaping the employee behavior. So Boeing have emphasized the cultural transformation by refining its value to prioritize the safety, quality, and excellence. So the company has invested in training programs to instill a safety-first mindset at all levels and establish the platform for employees to voice concern and contribute to ongoing improvement, ensuring the cultural transformation is deeply integrated within the organization.
For current solutions, Boeing focuses on collaboration with industry and regulators to ensure the safe return of the 737 MAX, including enhanced pilot training and advanced training tools. Next, collaboration with global authorities like the Federal Aviation Administration lead to improvements in the MCAS and software enhancements, with road testing verifying the aircraft safety. Lastly, Boeing's Global Aerospace Safety Initiative collaborates with stakeholders to enhance aviation safety. In 2022, Boeing completed over 30 safety risk management studies, showcasing its commitment to high safety standards.
Airlines also use currency hacking, diversify revenue streams, and optimize costs to manage financial impacts and exchange rate from the 737 MAX grounding. The effectiveness of software updates and new training restore the confidence in the 737 MAX. It enhanced regulatory oversight, improved the transparency and safety in aviation. Concern about unresolved structural issues in the 737 MAX still persists. Continuous, through the training and unbiased regulatory oversight remain the essential. Ensuring consistent through training for all 737 MAX pilots requires collaboration among airlines, training providers, and regulatory bodies.
Next, I will proceed to the effectiveness and shortcoming of pilot training and manual. So for effectiveness, pilots trained on the 737 MAX receive comprehensive initial training that cover aircraft system, procedures, and simulator sections to familiarize them with normal and emergency operations. Besides, pilots undergo type-specific training that focuses specifically on the system, procedure of aircraft models to ensure that pilots are familiar with the unique features of the 737 MAX. Simulator training programs were updated after the accidents to include scenarios related to the MCAS system and its fellow modes. Shortcoming in pilot training and manuals involve insufficient pilot training and inadequate manual updates to manage the redesign of MCAS. Boeing failed to provide training in the functions and operations of MCAS, which affected the pilots to identify any potential malfunctions of the software and handle emergencies during flight. The lack of awareness among pilots about the MCAS system and its potential will cause significant flight control issue. Besides, inadequate manual updates by Boeing did not sufficiently highlight the role and operations of the MCAS system, leading to confusion among pilots. Some pilots had limited experience with manual flight control, especially in high-stress or emergency situations. Insufficient experience or training in manual flight control will increase the challenge posed by such emergencies.
Moving on to the effectiveness of flight control enhancement, current flight control systems improve safety and efficiency with adaptable architectures, real time adjustments, and rigorous testings. These measures ensure high standards and continuous innovation in aviation, as well as adherence to strict guidelines like RTCA, is crucial for certification and reliability. Moving on to shortcomings, advanced flight control systems face challenges due to their complexity and reliance on software, raising reliability concerns. Rigorous certification processes further delay the adoption of these systems. Streamlining development, improving reliability, and expediting certification are essential to integrate advanced FCS into aircraft.
As for effectiveness, increase pilot control and feedback by collaboration with airline and flight crew to develop tailored pilot training program for the 737 MAX has empowered pilot with the necessary knowledge and skill for safe aircraft operations. So this tailored approach demonstrates Boeing commitment to prioritize the pilot control and feedback that ensure that training optimal enhance the pilot capability during the aircraft return to service. Point initiative to enhance the pilot control and feedback show effectiveness, but potential shortcoming in the implementation strategy require attention. The timeline for the implementation is critical and need improved communication and transparency to build stakeholder trust. Ongoing monitoring adaptation to safety standard, addressing resistance to change and robust change management strategy are essential for sustained effectiveness. While Boeing response prioritize safety and pilot empowerment, addressing this potential shortcoming is crucial for successfully integrating enhanced control and feedback practices in the aviation industry. The shift towards safety first principles demonstrate Boeing commitment to learning from past mistakes and prioritize the well-being of passenger and crew. So, by comprehensive training program aimed at instilling safety first mindset at all levels of the organization, has enhanced the safety protocol and promote a culture of continuous improvement. So, by providing the forum for employees to voice concern and contribute to the company evaluation, Boeing has fostered collaboration and transparency, promoting a sense of ownership and accountability. So, Boeing efforts in cultural transformation and external partnership are commendable, but challenges remain. Sustaining commitment to cultural change across all levels and aligning the practices industry-wide are crucial for lasting effectiveness. Overcoming this hurdle requires ongoing dedication and collaboration to ensure the safety and excellence post 737 crisis.
Moving to effectiveness, collaborative efforts such as Boeing specialized pilot training post 737 MAX tragedy enhance air travel safety. Regulatory mandates like the FAA's simulator training emphasize a shared commitment to aviation safety. Actions like the FAA Airworthiness Directive for MCAS training aim to improve safety and rebuild trust in the 737 MAX. On the other side, for shortcomings, collaboration faces transparency issues and engineering flaws, requiring regulatory enhancements. Next, engineering deficiencies and inadequate safety communication underscore the importance of transparency. Lastly, accountability lapses in reporting the safety issues, especially with the Boeing 737 MAX. Review the systemic shortcomings.
Currency hacking stabilizes cash flow but incurs costs. Diversifying revenue streams and optimizing costs improve financial resilience but require strategic planning. Hacking strategies can be costly and are not foolproof. Smaller airlines may struggle with the revenue diversification, and operational constraints can limit the cost optimizations.
So, to briefly conclude and summarize, the Boeing 737 MAX crisis, highlighted by two fatal crashes, exposed critical design flaws in the MCAS, leading to a global grounding and emphasizing the need to prioritize safety over profitability and public trust in aviation. Furthermore, cultural, technological, regulatory, ethical, and legal factors collectively influence decision making and safety protocols in aviation, revealing systematic issues that necessitate comprehensive reforms to rebuild trust and prevent future tragedies from occurring. Furthermore, the case study delves into two incidents which highlight the technical challenges and regulatory responses that underscore the importance of regulatory oversight in ensuring aviation safety and industry integrity. Last but not least, in response to the Boeing 737 MAX crashes, comprehensive measures have been implemented reflecting a collaborative effort to prioritize aircraft safety and industry standards while also addressing challenges faced by airlines due to the grounding. Lastly, the responses to the Boeing 737 MAX crashes are crucial for improving aviation safety, pilot training, industry collaboration, and regulatory oversight which emphasizes the need for continuous improvement and cooperation between stakeholders and regulators.
Our group reflected that the Boeing 737 MAX incidents highlight the multifaceted challenges of global business, emphasizing the need for safety, legal compliance, cultural understanding, and ethical conduct for sustainable growth and stakeholder trust.